Hello from AI Sciences and welcome to Data Science and Machine Learning full course in 100 hours. This is the complete roadmap for beginners. Let me introduce myself. I am Kashif Murtaza, your instructor for this course. I graduated back in 2012, majoring in computer vision and pattern recognition. I have taught several courses in the domain of data science and artificial intelligence. My interests and expertise are all in the domain of data science for more than a decade now. Almost all the data science core concepts can be traced back to probability and statistics. All paradigms of machine learning, including classification, regression, clustering, and reinforcement learning, can be modeled as probabilistic functions. Whereas a suitable set of assumptions about these models can be justified through statistical analysis on the available data. So I really like working in data science by establishing links to probability and statistics. Another important ingredient in this domain is the knowledge of linear systems. Several names are out there, for example, linear algebra, matrix computations, matrix analysis, and many more. It turns out that much easier and compact derivations can be made with this particular skill set. Several optimization techniques in general and almost all feature extraction techniques can be shown as special cases of different concepts in linear systems. I personally like to model problems in data science as problems requiring to solve a linear system at the end of the day. Most of my research work is in core computer vision techniques. Although modern computer vision rely mostly on convolutional neural networks, there still are problems that do not fit under convolutional neural networks due to several possible reasons, and there we are left only with core computer vision techniques. Also, theoretically as well as practically, I like how three-dimensional computer vision problems can be modeled using projective geometry. When I first started working in machine learning, it took me time to understand it. It looked mostly as a math course to me, but as I gradually moved on, it became the best exposure for me. In fact, I was working to select some machine learning model for the problem I was working on at that time, and I was repeatedly coming across support vector machine. That's a model in machine learning, very famous model, support vector machine. It motivated me to go into the details of this model. Believe me, when I returned back after getting everything about SVM, I was so fascinated by the unique kind of optimization and consequently the performance it offered. There is a deep link between machine learning and probability theory. Working in machine learning is always fun. When I first heard the term deep learning, I didn't give much attention, but soon it was everywhere. Just for my own satisfaction, I just trained a deep neural network on one of the datasets and found unbelievable performance. I used that model just like a black box. When I went through the theory of deep learning, it was so convincing that I divert almost all my attention to deep neural networks. If you have heard about the term universal approximation theorem, then maybe you are the next one to dive into the deep learning. Deep neural networks in general are interesting for image data, but there are specialized kind of neural networks that outperform in general. These convolutional neural networks are considered the game changers in the field of computer vision, particularly transfer learning, which is mostly possible in convolutional neural networks, allows several interesting problems to be mapped onto convolutional neural networks, even with small amount of data as well as computational power. I enjoy working in TensorFlow, for example, most of the times to model convolutional neural networks. Several problems, even in computer vision, like activity recognition and the problems that require videos of different lengths, are the problems related to sequence modeling. Recurrent neural networks are proven to be the best in these cases in practice. Like convolutional neural networks, recurrent neural networks have their own logistics and challenges. Most of natural language problems, natural language processing problems, NLP problems, are very well modeled by recurrent neural networks. I have also a great interest in recurrent neural networks. The most natural way of learning is reinforcement learning. It is a learning framework that has now its own place as compared to supervised and unsupervised learning. Most of the real-world problems with a huge scale are now being solved by reinforcement learning. Computers are now able to beat humans in very complex games due to reinforcement learning. About programming, after working in MATLAB for several years, I switched to Python a few years ago. It's amazing. I can say that because my undergraduation is in computer science, and I have enjoyed working in a lot of languages like C, C++, Java, PHP, C#, Perl, and even assembly language. Every language has its own strength. But when it comes to data science, Python seems to me the only choice. This is a list of publications that I have in the area of data science. And here about AI Sciences. AI Sciences is an e-learning startup offering courses and ebooks. Our latest unique student count is about 70,000, coming from 160 countries all around the world. This is the link of our webpage. Just sign up here and there you go in a world full of data science and artificial intelligence. Let me now turn to the specifics of this particular course. Data science is probably the fastest growing discipline these days. The growth, however, is multifold in terms of generality of applications covering diverse disciplines and consequently the financial charm. However, it is hard to master the skill set without unfolding the relationships and specifying the autonomy of the ingredients involved. Further, live implementations in leading languages like Python adds a significant improvement in understanding as well as getting a plug-and-play like knowledge. It also turns out that most of the concepts boil down to very basics of probability and statistics. However, each and every concept now has its own standing and logistics in practical data science. One may end up viewing different sections being independent, but they indeed are interlinked and mostly sequential. We therefore proposed this detailed course as independent and sequential. The term independent and sequential seem contradictory in this context, and that's probably correct. Let me explain why this contradiction holds in this case. We have divided the course into multiple sections where each section is a standalone and independent concept or even a course on its own. At the same time, however, we arrange these sections in a sequence such that each upcoming section builds upon the previous section and explore more independent concepts. So by the end of this course, a viewer will be equipped with almost all the concepts required to excel in data science with practical hands-on as well as with a strong theoretical foundation. Let me explain different sections step by step. We started with problem solving in Python for data science and data analysis. And we started with problem solving and finished at fancy indexing and plots in Matplotlib. No prior knowledge in any computer science language is assumed. Full fun with Python language. Reasonable treatment of data science packages like NumPy, Pandas, Matplotlib, Seaborn, and scikit-learn. After this section, a viewer will be a Python programmer as well as a reasonable expert of data science packages. This section is designed for anyone who wants to learn programming in general also. So shifting from Python language to any other language after this section will not be that difficult. This section, however, deals with in-depth treatment of data science packages, both for data manipulation as well as data visualization. The previous section focuses more on Python language, while this section focuses completely on data science packages and their efficient use. The packages covered in this section in detail include NumPy, Pandas, Matplotlib, Seaborn, Bouquet, Plotly, and Folium. As far as we know, this is the most comprehensive section on data understanding and visualization among the available ones. Further, the section is designed to reduce the dependency on core Python language to be treated independently as well. Two-dimensional and three-dimensional visualizations, interactive visualizations, and geographic maps are also covered. Proceeding in data science with being able to effectively play with data using famous packages makes progress much worse, and this section addresses this concern. Mastering probability and statistics in Python, like everyone notices, concepts in data science are not new. In fact, it is believed also that data science is merely a renamed version of probability and statistics. Without being biased to that extent, we will say that the practical nature of applications were uncovered earlier, even though the theory traces back to probability and statistics. One way or the other, knowing probability and statistics knowing probability and statistics makes a significant theoretical as well as practical difference. Most of the courses on probability and statistics, however, fail to link the data science practices and theory by merely focusing on axiomatic treatment of the subject. We build this section by keeping the practical needs of data science in mind, as well as the importance of theory. Wherever found important, we deliberately explain and show the relationships by derivations and even through Python code. This section builds a very sound basis for understanding the classical concepts in data science, as well as its more recent generalizations. We started with very basics of probability, went through inference and estimations, linked famous machine learning techniques with conditional probability, and finally showed the deep neural networks indeed learn a probability function eventually. Although several concepts, or even all, fall under the umbrella of probability and statistics, it turns out that most of the concepts have made their own practical place, mostly derived through engineering, with the name of machine learning. For example, the term overfitting is now referring to the area of machine learning. Machine learning brings its own set of practices to reach the demands of automations. Mastering these concepts is inevitable. This section actually focuses on a quick walkthrough of the concepts in machine learning and focuses on all the theoretical as well as practical concepts. We mostly cover applications using scikit-learn Python package and build machine learning pipelines in this section. We also elaborate more advanced areas of machine learning, which we later present as separate sections. Although knowing the sections we have covered thus far till now, including Python for data science, data understanding and data visualization, mastering probability and statistics, machine learning crash course, knowing all these sections brings a huge clarity of the field, but there is still one thing that brings the improvements in the results with a reasonable margin, and that is data pre-processing or data preparation. It turns out that most of the data science today rely on preparing the data suitable for machine learning models. An effective way of data preparation most of the times becomes a game changer. This section focuses on data preparation for machine learning models. We built this section to provide the understanding of why selecting features and transforming features is important. We also discuss practical issues with real data like missing values and non-numeric data as well. We discussed the performance improvements both in terms of execution time as well as the accuracy of the models. And we did explain the required mathematical background in a much friendly way. Finally, all the concepts are made more easily understandable by coding relevant examples in Python. With the availability of huge quantity of data as well as computational power, a relatively old machine learning model, artificial neural network, turns out to be the game changer in data science. It turns out that artificial neural network can approximate almost any pattern in the data, and further has much greater data utilization capacity as compared to most of the classical methods. With the recent rise of artificial neural networks, a lot of practical techniques are also discovered, particularly for artificial neural networks. Also, working with large amount of data brings its own challenges for learning algorithms. In this section, we address all these concerns and cover artificial neural networks in depth. We also introduce another framework called TensorFlow for working in deep neural networks. With this section in hand, a viewer can now target much larger machine learning problems than otherwise. Artificial neural networks in its most basic form are not that suitable for image data and for problems in computer vision. Convolutional neural networks are considered very well in the field of computer vision, particularly after introduction of AlexNet in 2012. It turns out, however, convolutional neural networks are not restricted to images only. They are everywhere now, ranging from audio processing to more advanced reinforcement learning, like ResNets in AlphaZero. So the understanding of convolutional neural networks almost is inevitable in the field of data science. Even most of the recurrent neural networks rely on convolutional neural networks these days. So keeping all these concerns in parallel, with this section, you can take your career to the next level with an expert grip on the concepts of implementations of convolutional neural networks in data science. In particular, in this section, we are going to learn about the importance of convolutional neural networks, the reason to shift from hand engineering to convolutional neural networks, the important concepts from absolute beginning with comprehensive unfolding examples with Python, practical explanations, and live coding, evolution of convolutional neural networks from LeNets to mobile nets, deep details of convolutional neural networks, examples of training convolutional neural networks from scratch, TensorFlow, state-of-the-art convolutional neural networks, and beautiful projects like transfer learning using face verification using transfer learning and neural style transfer. When it comes, however, to sequence modeling, the only effective solution is recurrent neural networks. Although CNNs or convolutional neural networks are considered great in the field of computer vision, particularly after AlexNet, it turns out that most sequence modeling problems on images and videos are still hard to solve without recurrent neural networks. Further, RNNs are also considered to be general form of deep learning architecture. It uses CNNs as a module whenever a sequence model problem falls under image or video or equivalent umbrella of input data. So the understanding of RNNs becomes almost inevitable in the field of data science. So keeping all these concerns in parallel, with this section, you can take your career grade up in data science. Then the training data is not always available, and the learner may have to learn through experience. This, in fact, is true in most of the cases, particularly when the learner is acting in an uncertain and non-stationary environment. Reinforcement learning, this particular section, targets that kind of learning. The learner needs to act in real time and hence has to decide its action in real time in response to the environment. Like just consider an example of self-driving car. Reinforcement learning brings its own challenges and their solutions, sometimes much different than solutions offered by supervised as well as unsupervised learning. Large-scale reinforcement learning problems do require knowledge of artificial neural networks to model a large-scale problem. So in this particular section, We will be covering the importance of reinforcement learning in data science, the important concepts from absolute beginning with comprehensive unfolding with examples in Python, practical explanation with live coding in Python, applications of probability theory and Markov-Decision processes, and model-free learning. By the way, for all this course, no prior knowledge is needed. We will start from the basics and gradually will build your knowledge in the subject. The course Data Science and Machine Learning, full course in 100 hours, is crafted to reflect most in-demand skills that will help you understanding the concepts and methodology with regards to Python. The course is easy to understand, expressive, comprehensive, practical with live coding, rich with state-of-the-art and recently discovered models by the champions in this field. This course is designed for beginners, although we will go far deep gradually. So I'm really excited about this comprehensive course. Don't wait. Just enroll this course and become a great data scientist and cover all the things that you need for your career in data science. Hope to see you in the course.